Hi, this is Crystal St. Pierre, and I am doing a rope technology presentation for my EDOE 538 course, Technology in Outdoor Education. We took a course called the Level 1 Rope Technician Short Course, and so this is one of the things that I did get from the class and thought that I could not only use it in my nature center setting, but that I could also use as a classroom teacher. So one of the many things that I believe I would be able to use is talk about the difference between simple, compound, and complex pulley systems. So that's what we're going to talk about. We're going to talk about simple pulley systems. There's the complex, and of course we have the compound pulley systems. And these are just sheets that were given to us as a part of the course. So we're going to talk about that. The first thing is a simple pulley system. There are certain objectives or rules that each system has to have in order to be categorized as a simple, compound, or complex. So the first one, to be a simple, all you need to do is count the support lines on a load, and that will tell you the mechanical advantage. And the mechanical advantage has to deal with the amount of force you're able to utilize in order to lift a load. And so if you look at the mechanical advantage here and you count the support lines, these are the support lines, 1, 2, 3, then your mechanical advantage is going to be 3 to 1. And that means that you're going to have 3 times as much advantage to one person actually putting in the effort. So the pulleys really able to help you lift a load that otherwise you would not be able to do on your own. If all the traveling pulleys in the system move toward the anchor at the same rate of speed, it is a simple pulley system. So if all of these are moving in the same rate of speed, then you'll notice that it is a simple pulley system. The numbers of the pulleys plus 1 in a simple system will also tell you the mechanical advantage. So how many pulleys is here? 1, 2, and then if you add plus 1, you'll get 3, and so that can also help you to figure out the mechanical advantage. Counting the pulleys plus 1 or counting all the support lines, and that will tell you. If the end of the rope is fastened to the load, the mechanical advantage is always going to be odd. So you'll notice that here the pulley is actually attached, which is also attached to the load, and that means it's attached to the load. And you can see the difference here, it's actually attached up top. But so anyways, with that being said, if it's attached to the load, then that means that the mechanical advantage is always going to be 3 to 1, and 3 obviously is an odd number. If the end of the rope is fastened to the anchor, the mechanical advantage will be even. So you'll notice that there's anchors up at the top of these 3, and so that means that it's going to be a mechanical advantage. It's even, so let's see what even number it will be. So if we go by the first way of finding out the mechanical advantage by counting the support lines, let's do this one. So let's count them, 1, 2, 3, 4, 5, 6. And so you have 6 support lines, so our mechanical advantage should be 6 to 1. If we use the other method where we count the number of pulleys plus 1, that should also tell us. So let's do this one as well. 1, 2, 3, 4, 5, plus 1 is 6. So both came out 6 to 1. And so if we check it down here, they are 6 to 1. And these are just 3 different ways. Here's the 3 pulleys here, and 2 plus 1 is 6. Here's 3, and 2 plus 1 is 6 as well. So these are just different ways that you can do a 6 to 1 pulley system. So to summarize, for a simple pulley system, these are the requirements that you would need. You'd use the whole throw, which is the whole line. Then you would count the support lines to get the mechanical advantage. It also helps you to know if the rope ends at the load, it's going to be odd mechanical advantage, and if it ends at the anchor, then it's going to be an even mechanical advantage. Alright, now let's go look at a compound pulley system. Now a compound pulley system has rules and objectives just like the other ones do to make it compound. And in order for it to be compound, it's going to be any combination of 2 or more simple pulley systems acting towards each other. and together, and so that makes a compound pulley system. And so some of the basic rules to get that is it's always going to be the product of the individual pulley systems. So for instance here we have a compound system. It is a 3-to-1 acting on a 5-to-1, which results in 15-to-1. So you'll see that they have the different 3-to-1, and then you'll have acting on a 5-to-1. And so just by adding this pressic here makes it a 5-to-1. And so if you do 5 times 3, it's 15, and so it's a 15-to-1. So you're getting 15 times the help just for one person, for one unit of help or effort. Then the other compound pulley systems is the greatest mechanical advantage that can be achieved while using the fewest number of pulleys is going to be 2 to the number of pulleys. So usually it's going to be 2-to-1 is the smallest simple pulley system you can have, 2-to-1. And so that's why you see a 2-to-1 here. And so what you can do is you can just keep using 2-to-1s, 2-to-1s, 2-to-1s. Just all these are 2-to-1s. And so all you would need to do is do 2 to the number of pulleys that you have. And so we have 5. 1, 2, 3, 4, 5. And 2 to the 5th power is 32. So it's 32-to-1. And that tells you the mechanical advantage there. Then the next one is you can attempt to rig with no rope drag, and that is what they are doing here. So see how you have the extra rope at the ends of these. This one is just going to be constantly rotated and used. And so this is a compound 8-to-1 depicting a way to reef pulleys with no rope drag. Okay, so you have 1, you have 2, and 2-to-1, and a 2-to-1. So 2 to the 3rd power is going to be 8. So 8-to-1, just referencing back to what we just learned here. Then the last one that you have is traveling pulleys will move toward the anchor, but not necessarily at the same speed. And you can adjust the system's efficiency in the knots at the anchor as the last step. And so this is what this one summarizes. There's a 3-to-1 in here, acting on another 3-to-1, which forms a 9-to-1. Rigging with offset anchors as shown will allow each separate simple system to collapse together, maximizing rigging space and efficiency. So that just shows you the last 2 points that I was explaining. And so for a compound pulley system, you're going to combine simple systems, you multiply them together, and then simply joining together at pressic or at rope end is basically how it turns out to be a compound pulley system. And so you'll see here that here's a pressic. This particular one does not have a pressic, but it's going to be at the rope's end. Same difference here, and then of course you can see the different pressics that you have along this one. Alright, so the last one that we have to use is a complex pulley system. And for a complex pulley system, it also has a set of rules. And for that one, it is going to be a pulley system that does not follow any of the parameters outlined in simple and compound. Okay, so they're not going to follow anything. So complex systems don't follow the simple or compound rules. And you can obviously see that here with the rigging. To determine the mechanical advantage of a complex system, you're going to use the T method. And so and then the last one is if pulleys ever travel towards the load, it's always complex. So if pulleys move towards the load, the system is complex. So you can see how those will move toward the load. And then the last one is the center pulley is a differential and equalizes the tension on the two forces. This is useful when the technician wants equal tension on a twin system. So you can see how that works as well. And using what it means when it says using the T method, that is a method that I will post either in a different video, because that is a whole different way that you need to learn how to do mechanical advantage. So this will conclude my video about the difference between complex, compound, and simple systems. But before I do, let's review complex pulley systems. The pulley can move toward the load, and it's going to use the T method. And like I said, we will cover that in a different video. And so we have our complex, we have our compound, and we have our simple pulley systems. And I would use this presentation perhaps even for a classroom teacher, as well as the nature center where I work. So this concludes it. Thank you.